Lecture 2 of Chapter 7, Permutation and Combination. So, learning outcome for this lecture. At the end of the lesson, students should be able to determine the permutation of a set of objects with conditions. So, now we have to follow the condition. Conditional permutation. When conditions are applied to the weighting arranged, it then happens that permutation is said to be conditional. For example, so for this learning outcome, we are going to focus on example only. So there will be more example other than the examples in lecture. So you have to try on your own in the tutorial and miscellaneous question. Example 1. 4 sisters and 2 brothers are arranged in different ways in a straight line for several photographs to be taken. Usually, this happens during Raya or Chinese New Year and Deepavali, right? So, how many different arrangements are possible if the 2 brothers must be separated? So, the 2 brothers cannot be together. It might be in between the 2 sisters or another 2 sisters, or so on. So, how can we imagine this arrangement happen? So let's say we can separate the 2 brothers by putting the 2 brothers in between the sisters. So first we arrange the 4 sisters. These 4 sisters can be changed between themselves. Why? Because the 4 sisters are unique. It's not identical. It's different people, different sisters. Sister 1, sister 2, sister 3 is not the same. So that's why we can rearrange the sisters. And then the 2 brother has 5 choices here. So it might be in these brothers. One will be here, another one will be here, or here, or here, or here. So they have 5 choices for the 2 brothers. So how can we calculate the ways? So the different arrangement for the 2 brothers, it will be 5p2. Why? 5 places, and we want to put 2 brothers only. So we only use 2 out of 5 places. And then the 4 sisters, because we have 4 ways to rearrange them, it will be 4p4 or 4 factorial. So if the first sister here, so we have 4 choices, 3 choices, 2 choices, and 1 choices. We all use the sisters. So that's why 4p4. So the answer is 480 ways. So you can take different picture. How many different picture for the arrangement? 480 different picture arrangements of the different arrangement. Okay. Example 2. In how many ways can 4 girls and 5 boys sit in a row if the boys and girls must sit alternate to each other? So we have to make sure it sits alternate. So we have to put girl as the barrier. If we put boys as the barrier, we have many places we can choose for the girls, right? So if we put the girls, because boys is more than the girls by 1, so it will be easier lah. So that's why these 4 girls will be the one that separated the boys. So it will be what? 4, choose 4. 4p4, sorry. And then the boys also, we have 5 boys and we have 5 places, will be 5p5. Okay, so another method is, this is 4 ways, this is 3 ways, 2 ways, and 1 ways, right? And then for the boys, these places have 4 boys can we choose. And then this one, if 1 boys have been chosen for the first place, this one we have 4, 3, 2, and 1. That's why we have 4p4 and 5p5. So the answer will be 2888. Example 3. 3 married couples have bought seats in the same row for a concert. So maybe they want to watch a concert Siti Nurhaliza, or maybe they want to watch concert Adele, right? So in how many different ways can they be seated? If each couple is sit together. So if they sit together, this word together, we must group them together. So another word, we can ikat dia orang sama-sama. Okay, so if we have 3 married couples, means that we will have 3 group. So this 3 group can be rearranged into how many way? 3 factorials, right? Or 3p3. Okay, and then in between this husband and wife also, they can choose they can change seat. Oh my god, my English. Okay, so for the first couple, it will be 2p2 of 2 factorial. For the second couple, so the same, and so on. So we have 2 factorial or 2p2 for 3 times, right? Okay, so what is the answer? The answer will be the answer will be 48. Okay, so for the second part, what is the question? Okay, let's take a look at the question first. If all the men sit together to the right of all the women. So we have to group what? We have to group the men together and group the girls together. So wife together, 3 wife together, 3 husband together, and the wife should be on the right side of the husband. So we cannot change between these two big group. We cannot change because the wife should be on the right side of the husband, always on the right side of the husband. So one way only to choose between these two. So we don't have many ways, only one way. And then in between this wife, they can change the seat. And then in between the husband also, we can change the seat. So it will be 3p3 or 3 factorial multiplied with 3 factorial. So the answer will be 36. Example 4. How many 4-digit even numbers can be formed from the digit 0, 1, 2, 3, 4, 5, 6, 7 to make up numbers between 2000 and 6000 for A without repetition, for B with repetition? What it means by repetition? If we have used 2 in front in the first place, we cannot use 2 for the next places. Okay, so let's do for question A first. So we have 0, 1, 2, 3, 4, 5, 6, 7. To get the number 4-digit number between 2000 to 6000. So for the first digit, so we can use what? We can use 2, 3, 4, 5 only. 2, 3, 4, 5 only. Because it always in between 2000 and 6000. So we have to ignore 6 already. So for the first places, we have choices of 1, 2, 3, 4. Right, 4 choices. But remember, if we choose 2, the number at the end, it should be even. So the choices will be 0, 4, 6 only. But if we choose 3 as the 1000 digit, so the choices for the even number at the end of the digit, at the end of the numbers will be 0, 2, 4, 6. So 4 different choices. So what we need to do is to separate between if we choose the even number on the first place or odd number for the first place. So first case, if first digit is 2 or 4. So this is the table. So this is for the first digit. So it can be 2 or 4. So we have 2 choices between 2 or 4. And the second digit, it can be any digit except for the first digit that you have choose. So how many digit we have? 1, 2, 3, 4, 5, 6, 7, 8. So 8 digit minus 2 digit that already fill the first and the last. Okay, so they choose the 4th digit first. Okay, so let's say because why? Because we have to make sure it's an even number. Okay, so we have to skip the second digit. So we go to the 4th digit. From the first digit, the next one should be the 4th digit. So the 4th digit, we can choose either 0, 2 or 4. We cannot take both. So because one of it will be on the first digit. And then 6. So how many choices? 0, 2 or 4 and 6. So 3 choices. Okay, so now we have choose 2 even number from the 8 numbers we have, 8 digit we have. So what's left is 6 digit. That's why the second digit we have 6 choices only. And the third digit we have 5 digit only because we have choose 3 digits from the 8 digit to fill in the first, second and fourth digit. So multiply all of this, we get the answer 2 multiplied by 6 by 5 by 3 is equal to 180. So this is for the first case. This is not the final answer, because we have the second case where the first digit is 3 or 5. Okay, let's say if the first digit is 3 or 5. So how many choices for the first digit? We have 2 choices, which is 3 or 5. And then we have to check the last digit first. So the last digit, we only have how many even number? Because it should be even. At the end should be even. So it will be 0, 2, 4, 6. We didn't use any of this number on the first digit. So 4 choices. And then for the second and third digit, it will be 6 and 5, the same as the first case. So the number of ways that we can rearrange this is 240. So the final answer should be adding up between the first case, which is 180, and the second case, 240, which is equal to 420. Okay, this is without repetition. We cannot repeat the number that we have used. Now, the next question. With repetition means that we can use the same number on the every of the places. So, the first digit, we can use 3, 2, 4, 5. So we have 4 choices. So we don't have to worry about, oh, we have to put even at the end. 2 cannot, because at the end it should be 2. No, because we can use 2 again. So it will be 2 here also. The fourth digit also can be 2. Okay, that's why we have 4 choices for the first digit, 4 choices for the fourth digit. Why? Because we have 4 even number. And then for the second and third digit, we have 8 choices. Why? It's from the all 8 digits given. Okay, we can use repeatedly. So it will be 2, 2, 2, 2 pun boleh. Okay, that's why we have 4 multiplied by 8, multiplied by 8, multiplied by 4. Okay, but this is not the final answer. Why? Because if we have 2, 0, 0, 0, it's not in the range. Because it must be in between 2,000 and 6,000. Between. So 2,000 is not included. That's why we have to subtract 1 data, which is minus the 2,000. Okay, so that's for example 4. Okay, example 5. How many different arrangements are there for the letters of the word arrangements if A begin with R and A ends with E? B, the 2 letters E are separated. C, the 2 letters E and the 2 letters A are together. D, the consonant letter G, M, T, S are together. The 2 letters N occupy the both ends. Let's do this. Okay. So for question A, begin with R, end with E. So we have arrangement. How many words we have? How many letters we have? A, R, A, N, G, M, E, N, T, S. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Oh, we don't have S. Sorry. So 10 arrangement. So we can choose 10 out of we can permutate 10 letters of 10 letters. So that's why it's 10 arrangement. Okay. Are you sure? Let's check the question. We have S lah yang. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I spell it wrongly? Okay, it should be here, E. So it will be 12, including the S, 12 word letters. And then it must start with R and E, so we have to put R and E at the end. Okay, so if we choose R here, means that we have another R. Okay, we choose to permutate in between of the R and E letter. But because we only have one R, so it's not identical. And then what are the identical? So we have A, identical A, and then we have identical N. And then for E, because the E is at the end of the words, and it must be E, so we only have E in the middle. So that's why we have to divide with 2 factorial and 2 factorial only. So the answer should be 10 factorial divided by 2 factorial, 2 factorial. Okay, so for question B. The two letter E are separated. Okay. So how to separate the letter E? We can put in between all the arrangement of the other letters. So we arrange all the letter except for E. So how many places the E can be put? So we have 1, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 places to put the 2 E's. So 10P2. And then arrange the 10 letters without E. So how many letters without E? It will be 10 letters. And because we have identical letters, so we have to divide with the identical. So we have identical A, we have identical R, and we have identical N. So the answer should be 11P2 for the E. And then because the 2E are identical, we have to divide by 2 factorial. So the different arrangement should be 11P2 divided by 2 factorial. And multiply with 10 factorial divided with 2 factorial, 2 factorial. So this one is to arrange the E. This one is to arrange the other letters. So the answer should be 24,948,000. Okay. For question C, the 2 letters E and the 2 letters A are together. So bila together, we have to put it together by ikating them. So ikat them together. So A together, YR together, it should be A together, E together. So I think maybe they confused between this letter. So let's say R together. Okay, so we put A together, R together as one words, then the other letter will be on their own. So how many letters we have? For the other than A and R will be 8. And then this R and A is one group and one group. So we have 10 letters. So you want to arrange these 10 letters. And then we have identical E for the arrangement and identical N. That's why we have to divide with 2 factorial, 2 factorial. And then in between A and R, they actually can be rearranged. But because these A and R are together, so we can just ignore their arrangement. Because if we change the place between them, it will be the same lah, R juga. So that's why the answer will be 10 factorial divided by 2 factorial, 2 factorial. Which is 907,200. Question D. The consonant letter GMTS are together. So we have GMTS. So other than that, arrange them. So GMTS together. So what's left? So we have total of 12. So minus 4 will be 8. So 8 together with GMTS. So we have 9 letters. So that's why 9 factorial. And then we have identical of A, identical of R, identical of N, and identical of E. So that's why this 9 factorial divide by 2 factorial, 2 factorial, 2 factorial, and 2 factorial. And don't forget GMTS are not identical. Means that we can group we can rearrange their position in the group. So that's why we'll be multiplied with 4 factorial. So the answer will be 544,320. Okay. And last one, question E. The 2 letters N occupied both ends. So N both ends. Wow. So we put N at the end of the letter, which is in front and at the end. And then what's left is in middle is 10 arrangement. Okay, 10 letters. So 10 arrangement. So 10 factorial. But because we have 2A, 2R, and 2E, so we have to divide with 2 factorial, 2 factorial, 2 factorial. So these 2 N, if we change their position also will be the same now, because N are identical with each other. These 2 in front and at the end will be identical if we change the position. So the answer will be 453,600. Okay, so that's all for the permutation. For the next lecture, we are going to discuss on the combination. Okay. Thank you, class.